Today's goal is to sketch radical, exponential, and trigonometric functions. Maybe you're thinking like, ugh, that's a lot to do in one day, but I want you to see how similar these aims are. Okay, let's start with a radical function. As an example, let's just sketch the parent radical function, meaning the most basic radical function, which is square root of x. It's a function if it's equal to y or equal to f of x. If on a test you don't remember what this looks like, and you are not in the pre-calc room, so you don't have any cheat sheets around, just substitute in numbers. Let's try 0. Square root of 0 is 0. Let's try 1. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. I'm just picking numbers that are convenient to use as x values. If you were to plot that, you've got 1, 1, right here, 2, 3, 4. We got to go all the way out to the x value 4 to get the y value 2. 5, 6, 7, 8, 9 to get the y value 3, and so on. Oh, that's right. It's that shape that increases quickly near the vertex, increases slower out here. That's why we say radical functions increase at a decreasing rate. If you tried to put -1 in, you get square root of -1 is I, an imaginary number, which we don't know how to graph yet. So that's why we say it's got a vertex, a starting point at the origin, and then continues off to the right. All right, if we wanted to sketch y equals 4 times the square root of x minus 2 plus 5, it's going to have this shape. But the 2 is going to move the function 2 units to the right. What? I thought it'd be to the left because it's minus. Nope. Keep in mind, right and left is the opposite of what you would expect, but up and down is exactly what you expect. So it's going to move these 5 units up. And then the 4 causes a vertical stretch. Think about when you stretch your arms up. Stretching your arms makes you taller and skinnier, so it's going to be taller and skinnier. As a very rough sketch, we can simply say the vertex is moving from 0, 0, 2 units right, 5 units up, so it's going to be here. And then instead of being sort of this shallow, it'll be stretched up like this. That's enough for a sketch. You can clearly see its shape. You can clearly see its domain, which would be from 2 onwards. You can clearly see its range, which would be from 5 onwards, including, of course, 2 and 5. That's enough for a sketch. Okay, exponential functions. Again, maybe you're thinking on a test, I'm asked to sketch some exponential function. I know a really basic one would be 2 to the x, but I have no idea what that looks like. Well, let's plug in values. If you plug in 0, 2 to the 0, anything to the 0 is 1. Plug in 1, 2 to the first is 2. Plug in 2, 2 squared is 4. Plug in -1, 2 to the -1, oh, that's 1/2. Plug in -2, 2 to the -2, that's 1 over 2 squared. So that's a 4th. Plug in -3, 2 to the -3 is 1 over 2 cubed. Oh, that's an 1/8. Oh yeah, now I remember. It's got an initial value at 1. 2 to the x is, of course, the same thing as 1 times 2 to the x. These y values are getting really big really quickly as you use bigger and bigger x values. But if, for example, you're at -1, that has the y value in half. -2 has the y value in 4th, blah, blah, blah. Oh, I remember. It's got a horizontal asymptote at y equals 0, which we can emphasize sort of with a dashed line. Okay, next example, this was example 3, example 4. Let's sketch g of x equals -2 times 3 to the x minus 4. Changes right by the x value are going to move it left and right. I can see I'm not moving left and right. Adding or subtracting some value away from x is going to move it up or down. Remember, that's intuitive. Minus, oh yeah, we would think it's going to go down 4 units. And negative signs cause reflections across Think about if you flipped it across the x-axis, now it's going to have this shape. So let's move it down 4 units. That's going to affect the horizontal asymptote, which we can now draw in at -4. And now instead of increasing at an increasing rate, we're going to flip it upside down. Now it'll be decreasing at an increasing rate. See, it decreases sort of slowly here. It's decreasing really dramatically here. Don't want that to be your bank account. Okay, this is enough. Again, you can see the shape decreasing at an increasing rate. You can see the domain. It goes forever left and right. You can see the range. You're using negative y values up to, but this time not including -4. So knowing the shape and the domain and range means this is enough. This is a nice sketch. Okay, 2 more. Let's look at trig functions. Maybe you're thinking to yourself, if I were asked to sketch a sine function, I don't super remember, what values are convenient to put into sine? I would say one convenient value is 0, because that's this angle here. Sine is its y value, so the sine of 0 is 0. One easy angle would be this guy at pi/2, because its coordinate pair, oh yeah, sine is the y value of 1. At pi, we again get this y value, the sine value of 0. At 3 pi/2, sine is -1. You go back around to land at 2 pi. Again, sine of 2 pi is 0. So I sort of mark in these zeros myself. Go up to 1, I go down to -1. I'm just going to connect the dots. And then it keeps going. I can see again, it's got this nice curved shape. If I wanted to, I can tell the domain is -infinity to infinity. Make sure you draw these arrows because it keeps going in both directions. The range would be -1 to 1, because these y values are just going to keep bouncing between -1 and 1 forever. Okay, if you wanted to know cosine, now you're looking at the x values. Let's put it on the same graph so you can sort of see what's happening. Cosine of 0 is the x value 1. Cosine of pi/2 would be that x value 0. Cosine of pi, -1. Cosine of 3 pi/2, 0. Cosine of 2 pi, 1. Oh, so this time I'm starting at a maximum, and I'm ending at a maximum. The period is 2 pi, meaning you're just going to keep going around and around the same shape. Between the maxes, I'm landing at a min, and then I'm going to cut through the x-axis halfway between there. So don't draw a straight line between, draw this nice curve. You're just unwinding the circle. It's got this same curvy shape, in fact, the same domain and range. It's just starting at a maximum instead of starting at the midline. Okay, last example, example 6. Let's sketch h of x is -2 cosine of x/3 plus 1. By now, I hope you're recognizing I'm doing something to change the x values unique to sine and cosine is looking at b. This is the same thing as 1/3 x. And the b, the coefficient of x, is equal to 2 pi over the period. Okay, I can cross multiply. I get that the period is 6 pi. That's going to stretch out my function. But this is what you should recognize. The negative sign causes a reflection across the x-axis. The 2 is going to cause a vertical stretch. In sine and cosine language, we call that this distance between the max and the midline the amplitude. Intuitively, we saw what was happening here. When you're multiplying y values by a big number, it stretches them out. We saw the same thing happening here. If you were multiplying by a 4, it would have made it really shallow. But we're just quantifying that. We're just describing it with this language, calling it an amplitude. And then the 1, hopefully you're seeing, adding or subtracting some value at the end is just going to move it up or down. Again, we have nice language for this in terms of trig functions, but it's just moving up and down the function. So it's moving the whole function up. We say its midline is at y equals 1. Instead of its midline being the x-axis, y equals 0. I personally like to use the midline as a centering value. So draw my axes. I'm going to use y equals 1 to center my graph. Okay, amplitude tells me how far I need to go above and below my midline. I'm thinking of the amplitude as 2, not -2. So I know I need to go to above, up to 3, to below, down to -1. Okay, now I'm thinking about period. My period is 6 pi, so I'm going to get this nice full cosine shape from max to max once I go away with the distance of 6 pi. Finally, I'm thinking about this negative sign. Cosine usually goes from max to max, but if I flipped it upside down, now it's going to go from min to min in this width of 6 pi. In between the mins will be a max, and then of course you got to hit the midline in between there. I'm going to connect my dots with a nice smooth curve. I could draw another period if I'd like. Oops, sorry. I'm going to go another 6 pi. Again, that takes me from min to min. Halfway between, I got to hit my max, 2 units above my midline, and hit my midline in between. Again, it goes on forever left and right, so throw these arrows so we can really clearly tell the domain will be -infinity to infinity. This time my range, since I moved it up and I stretched it out, now my range is from -1 to 3, where we are hitting those y values, -1 and